Step outside right now and look up. Even if it's cloudy, even if it's the middle of the night, the sun is there. It has been there every single day of your life, every single day of your parents' lives, every single day of every human who has ever lived across 300,000 years of our existence. It has never missed a morning, not once. Now imagine it's gone, not dimming, not fading, not a slow cinematic death millions of years from now that we've been casually promised in documentaries. Gone tomorrow, between 1 second and the next. What actually happens? The answer moves faster than you think, and it is so much worse than darkness. Because most people, when they hear this question, go straight to the obvious answer. Everything freezes, everything dies, the end. And yes, eventually, that's true. But the real question is the sequence. The timeline. What happens in the first 8 minutes? What happens in the first hour? The first week? The first year? Because the death of Earth without the sun is not a single event. It is a cascade, a slow unraveling of every system that keeps this planet alive, playing out in a specific order, on a specific schedule, with some surprises buried inside it that nobody talks about. So let's go through it, beat by beat, second by second, starting with the moment it happens. The sun disappears at, let's say, 9 a.m. on a Tuesday. You don't know yet. Nobody does. Because here's something most people don't realize. Light from the sun takes 8 minutes and 20 seconds to reach Earth, which means the sun could vanish completely, and we would have no idea for 8 minutes and 20 seconds. We'd still see it in the sky. We'd still feel its warmth. Birds would still be singing. Someone would still be stuck in morning traffic. And then at 9:08 and 20 seconds, the sky goes black. Not dark, black. The kind of black that has no bottom to it. Instant, total. No sunrise fading into dusk. No warning, just light. And then the absence of all light simultaneously. Every solar-powered system on Earth fails instantly. A significant portion of global electricity generation, gone. Traffic systems, communication networks, anything running on real-time solar input. And the psychological impact alone of 8 billion people experiencing sudden total darkness in the middle of a clear morning would be unlike anything in recorded human history. But that's just the beginning, because 8 minutes after the sun disappears, something else arrives. Gravity. Here's the part that most people miss completely. When we talk about the sun disappearing, we only think about the light. But the sun doesn't just give us light. It gives us our orbital path. It is the gravitational anchor that keeps every planet in this solar system tracing its specific loop through space. And here's what Einstein's general relativity tells us. And this is where it gets strange. Gravity, like light, travels at the speed of light. Which means if the sun vanished, we wouldn't feel the gravitational change any faster than we'd see the visual change. 8 minutes and 20 seconds. For exactly 8 minutes and 20 seconds after the sun disappears, Earth would continue orbiting a gravitational point that no longer has anything in it. We'd be circling a ghost. And then at 9:08 and 20 seconds, the same moment the sky goes black, Earth's orbital path dissolves. We stop curving. We go straight. Earth launches into deep space at roughly 30 kilometers per second, our current orbital velocity, in whatever direction we happen to be moving at that exact moment. No brakes. No correction, just a cold, dark rock flying in a straight line into the void. But here's what's strange. In the short term, the next few days, that might not be the thing that kills us first. Let's talk about temperature, because this is where the timeline gets genuinely harrowing. Earth's surface temperature is not solely dependent on direct sunlight hitting it in real time. The planet has thermal mass. It stores heat the way a brick stores warmth after you pull it from a fire. The oceans especially. They hold enormous amounts of thermal energy built up over billions of years of solar input. So Earth doesn't freeze instantly, not even close. In the first week, average surface temperatures would drop by roughly 17 degrees Celsius. Uncomfortable, dangerous for vulnerable populations, but survivable in most places with adequate shelter. By the end of the first year, negative 73 degrees Celsius on average across the surface. Within a few years, negative 100 degrees Celsius and falling. Eventually, Earth would stabilize at around negative 240 degrees Celsius, just barely above absolute zero, the temperature of deep space. But here's something nobody talks about. A 2014 paper published in Astrobiology by researchers, including David Grinspoon, pointed out that Earth would not become completely uninhabitable in the conventional sense immediately, because the oceans, insulated by a layer of ice forming on their surface, would retain liquid water beneath for potentially hundreds of thousands of years. The ice becomes a blanket. Geothermal energy from Earth's core, which has nothing to do with the sun, continues to heat the ocean floor. Hydrothermal vents, the same systems that harbor life in total darkness at the bottom of our oceans right now, they would keep running, and the ecosystems built around them. Chemosynthetic bacteria, tube worms, shrimp adapted to complete darkness. They might survive indefinitely. Life wouldn't end on Earth. It would retreat, contract, pull down into the deep, dark water, and keep going. And here's where it gets specifically strange for humans. A 2012 thought experiment developed by physicist David Brin and expanded upon by futurists at the Global Catastrophic Risk Institute suggests that a technologically sophisticated civilization with sufficient warning and sufficient resources could theoretically survive the loss of a star. Not forever, but long enough. Nuclear fission reactors provide heat and electricity. Deep underground habitats insulated from surface temperatures. Hydroponic food systems running on artificial light. The same geothermal energy that keeps those deep-sea vents running could, in theory, be tapped at scale. We wouldn't need the sun to survive. We would need each other, and every power grid, and every greenhouse we could build. It would be the most ambitious engineering project in human history, begun in darkness, with no dawn coming. But let's sit with something deeper for a moment. The sun is not just a star. Not to us, not psychologically, not historically. Humans looked up and understood, on some pre-rational level, that the light was the reason they were alive. They built Stonehenge aligned to the solstice. They built the pyramids aligned to specific solar positions. They oriented cathedrals to catch the morning light. They buried their dead facing east. For 300,000 years, the sun was the one constant, the one thing that never betrayed us. And here's what that means. The darkness that would fall 8 minutes and 20 seconds after the sun disappeared wouldn't just be a physical event. It would be something our nervous systems have no framework for. Something that reaches below conscious thought into the oldest, deepest layer of what we are. Because we are not just biologically dependent on the sun, we are psychologically constituted by it. Our circadian rhythms, our serotonin cycles, our concept of a day, our sense that time moves forward because morning follows night and light follows dark. All of that, gone. In a single second. The question of whether humans could survive the physical conditions is almost secondary to the question of whether we could survive what it means. We talk about the sun the way we talk about the ground beneath our feet. Not at all, because it's always there. Because something that has never failed you doesn't register as a thing that could. But scientists think about this more than you'd expect. Not because they think the sun will vanish. It won't. Not like this. Not in any scenario physics currently allows, but because the question forces a reckoning with something we avoid. Everything we have built, every city, every archive, every piece of music, every satellite, every field of wheat, every relationship, every memory stored in a living brain, exists because one specific star showed up at a specific distance from one specific planet and stayed there for 4.5 billion years. We did not earn that. We did not choose it. We inherited it. From the universe, for free. And we have spent most of our history either worshiping it or completely ignoring it, with very little in between. Maybe the more honest response is something quieter than either of those, something closer to the feeling you get watching the last light leave the sky on a winter evening. A kind of gratitude that doesn't have a word in English. But most languages that grew up closer to the land seem to have something like it. Tomorrow morning, sometime around dawn, light will enter whatever room you sleep in. It left the sun 8 minutes and 20 seconds before it touches your face. It crossed 93 million miles of absolute nothing to get there. It has done this every morning for 4.5 billion years without being asked. And somewhere in the deepest part of your biology, below thought, below language, below anything you could explain to another person, some ancient part of you will recognize it and relax, the same way it has every morning, for as long as there have been eyes to open.